Hi, welcome to Fun with Information Technology. I am your favorite IT teacher, Miss Shauna Day. And today we're going to jump right into our topic of algorithms and program design. By the end of this lesson, you should be able to, 1, display the ability to explain what an algorithm is. Number 2, demonstrate the ability to identify variables and constants and distinguish between them, and develop the skills to use the correct data types to solve a problem. Let's get into it. Define the term algorithm. Now, if you're like me, I find it difficult to pronounce this word. I don't know, something with my language barriers, but you'll get it eventually. An algorithm is a set of steps used to solve a given problem or a complete specific task. Developing an algorithm means creating a step-by-step way of solving a problem or carrying out a task. There are different algorithms that can be used to solve the same problem. One must decide which algorithm is the best and why this is so. Flowcharts and pseudocodes can be used to represent an algorithm. Now, algorithms have 4 very important attributes. 1, they must be precise. 2, they must be unambiguous. 3, they must finite, that is, terminate after a finite number of steps. Use start or stop. The instructions must be in a logical sequence or must be in the correct order. Now that we have an understanding of what algorithms are and their attributes, bear those things in mind. We're going to now have a look at identifying variables and constants. Now, what are variables and constants? So variables are symbolic names given to data where the value of the data stored may change during the execution of the problem. In effect, a variable is a named area of memory used to store data. Constants are symbolic names given to data where the value of the data cannot change during the execution of the problem. Many constants, such as pi, are built into programming languages. Now, concept of variables. So a variable is a location within the memory that stores a particular value. A name used to identify a variable is called an identifier. Suitable names to identify a variable to store the first number, number 1, a or even x. Suitable names to identify the variable to store the second number would be num2, a, or even y. Suitable names to identify the variable to store the result would be sum, result, answer. A variable must not begin with a number or special character such as a percentage, a pound, a $sign, etc. Let's have a look at flowcharts. Now, a flowchart is a diagram that represents an algorithm, which is a set of steps used to solve a given problem or complete a specific task. A flowchart is made up of shapes and arrows that connect those shapes. It's usually drawn from top to bottom or left to right. It is read from top to bottom and left to right. It's read by following the lines with arrows from shape to shape. It shows each step as a shape. The order of those steps is shown by connecting them with arrows. It is something broken down into many steps to provide a lot of detail about exactly what is happening. Now let's have a look at this example of the input, process, and output chart. And then we'll have an example of the flow chart. Now the input or the IPO chart would have the information of input, weight 1, weight 2. And the processing would be total equal weight 1 plus weight 2. And the output would be the total. Now, if we have a look at the flow chart, we would see the stop or start, enter weights 1 and 2, total equal weight 1 plus weight 2, display total, and stop. So these are just examples of how using the IPO chart to create a flow chart. Now, before we look closer at the flow chart, there's just some more information I want to give you on data type as it pertains to a value and variable. Now, a data type defines what kind of value a variable can hold. We have the integer data, character data, strings, Boolean, and real, which is in your decimal. If you have a look on the screen, you will see a diagram showing the type and their values. For the integer, we have from -1, 0, 1, 2, and onwards. For the real, we have 2.1, 0.2, 1.2. For the character, we have Q, G, the and sign, and the pound sign. For the string, we have uplifted commas David and uplifted commas school. We will see an explanation and an image. The first shape is a terminal. These shapes are usually filled with words like start or begin to tell us where the flowchart starts. As you can see, this would take the form of an oval type shape. It also ends or stops to show us where the flowchart ends. The words that you use to show the start or end of a flowchart are up to you. We then have the decision shape. The decision shape shows where a decision needs to be made. The shape contains a question. 2 arrows should come out of this shape. The answer to the question determines which arrow you follow out of the decision shape. 1 arrow comes out from the bottom and 1 from the side. We next have the input or output. So this shape is used where we need to get data, when we were asking for data, or where we need to accept data, or where we get results, or when we need to show results. As you can see, this symbol is a parallelogram. Thanks my primary school teacher, I remember that. Processing. Now this shape shows something that has to be done or an action that has to be taken. The text in the rectangle almost always includes a verb. And as you can see, the shape is a rectangle. We then have the connector. These are lines with arrows that connect each shape to another. You will read a flowchart by following the lines with the arrows from shape to shape. All right, so bear in mind what we're doing in this lesson is, again, giving information and preparing you to effectively solve your problem. All right, so these are for students who would have missed the simple explanations that are vital to you properly dissecting and solving a problem. Let's get into the pseudocode. Now, the pseudocode is a simple way of writing programming code in English. Pseudocode is not actual programming language. It uses short phrases to write code for programs before you actually create it in a specific language. Once you know what the program is about and how it will function, then you can use pseudocode to create statements that achieve the required results to or for your program. So a pseudocode is also called structured algorithm. Now, on screen, you would see a general structure of writing a pseudocode. Let's have a look at it. In our header, we have algorithm's name or title. We then have the declaration, which would be a brief description of the algorithm, declaration of constants, and declaration of variables. We then have begin, where you would find prompt or output statement, comments, and input statements, along with processing statement, output statement with results, which also would bear comments, and then the end. Here is a sample of a pseudocode. All right, then we're going to see the end of our lesson. I trust that you have taken the general understanding and you are ready to put it into practice. Please be advised this lesson is a continuation lesson where we're going to actually get into solving CSEC problem questions. All right, so this was fun with information technology. I am your favorite IT teacher, Miss Shanette Day. Bye.